everybody that's here, just a quick intro is that today we're not going to be trying to make any games or anything, really anything cool. What today is about is just getting people to be somewhat comfortable with working with this game engine, meaning Unity. Just because we have a game jam that's coming up, and we want people to be able to go into it and at least be somewhat comfortable with working in this environment, because it is, Unity is a massive application that you can do a million things in, but we're not going to try to cover a million things. We're going to try to cover, okay, I can open this up and I understand what's on my screen, and now I can start looking for things, right? Or I can start doing things. So that is the objective. Now, we also have no point, like agenda to get to. So if at any point anybody has any questions about what we're going on, please just say, hold on, that's not on my screen, or hey, what are you doing here? What did you mean by this? Or anything like that. Just don't worry about the whole hand raise thing. Just unmute your mic and say, yo, what's going on right here? What are you guys doing? And we can, share your screen. We can walk through it. We just want everybody to sort of go at the pace that we can. So anytime you have a question, just let me know. We are going to do this kind of from scratch. I'm even going to create the project and everything from scratch. So, and there's a few caveats that we might bump into. So, again, if anybody says anything, just let us know. Okay, so from scratch, we are going to start up Unity and get us a new project going. I do have, just so you know, I have like I don't know, a sample project running on this other screen. So if you are curious, that's what's going on. So I may pause and say, hold on, let me look at this. But yeah, so we're gonna create a new project, and the template for 3D is fine. You, again, don't need to learn all this, and we're gonna just name it, what did I say, Unity Intro, doesn't really matter. Unity Intro 00. And this will take a minute. Unity is a bit of a beast. You are essentially running a game inside an editor. So yeah, naturally you're going to have a lot of layers of complexity on top of that. So it does take a little bit of getting going. But and if those of you that followed the little instruction thing that I threw out there, you may see some, oh, I already did that. That's fine. Just, go with the flow. But there we go, starting up a new project. I'm also going to have my layout set to default, just so that you guys, I run my layout a little different than the default one is, and I'll show you guys why, but you guys are welcome to set yours up any way that you want. This is just specifically so that you can follow along with how I've got things going on here. Man, this is taking forever. All right, here we go. Okay, so as I mentioned, I'm going to reset my layout to factory default just so that you guys will see how to walk through this. This is what Unity looks like from day one. If you just install it and whatever, you have some stuff, right? So if you would follow with me, and again, anybody, pipe up if you're like, what'd you click on, or I didn't see that, or anything like that. Okay. So at the top, we're going to click on Window, and we're going to go to Layouts, and we're going to go to Tall. That's going to make it look like this. And by the way, we're just going to go through the setup stuff before I really start showing you guys what's what. All right, so we've got this. Let's put some stuff over here. We're going to then click on Window, and we're going to go to General, and we're going to click on Console. And for you web devs, this is exactly what you think it is. This is where you spit out text, or you get errors and things like that. We're going to drag this console window down to the bottom, and it's going to auto-fill right here so that you kind of look like this. And then we're just going to drag this down to get it out of the way a little bit. And then we're going to click on this little line and we're going to just slide everything all the way over to the right. So we have a nice big open scene view. All right, I'm going to assume everybody's with us. If not, you're going to pipe up and say, hold on, right, right, right. All right. All right, next. Up here we have two tabs, Scene tab and the Game tab. Just so you guys know, Scene is where you're building everything. Game is what it looks like if you're actually playing this game. So we're going to take this Game tab, we're going to drag it over here to this side so that it populates like this. Let go, and now we have essentially a split screen here between Scene and Game. Everybody with us? Good. All right, almost there, guys. All right, the other thing we need to do just to be all set up is down here on the lower right-hand corner where it says auto generate lighting. It probably says off. If it doesn't, leave it alone, but if it does, click on it. That's going to pop up this window that says lighting, and we just want to click on this little box right here that says auto generate. And then we can close that. Boom. All right, everything good? Now, the only other thing we need to do is right here, see this little slider? We're going to slide that all the way to the left. And we are now pretty close to perfect, at least for development. All right, so everybody welcome to the Unity engine. Again, millions of things you can do in here, super powerful tool, but we're gonna work on some basics just so that you at least have a basis for starting. Identifying some of the stuff that's going on in here. Over here, under hierarchy, we have, and you can, by the way, click on this is what's called a scene. You can click on the little arrow, and this is the stuff that's in the scene. Currently, we have a camera and a direction light by default. That's it, nothing else. Okay, so the stuff that we don't have anything, essentially anything in our scene right now. Now down below here, where it says projects, these are the files that are in our project. So we have our assets, and under that we have our scenes folder. In our scenes folder, we actually have this sample scene. So this is exactly what you think it is, just like File Explorer in Windows or whatever. It's just, I mean, it literally is that underneath the hood into it, the asset scene, so on and so forth. Now, so let's make something. Let's start. Up here in our hierarchy, where everything scene is, we're going to click on Create Empty. And you'll notice that this pops up a little item in our scene called Game Object. Now over here in our scene view, well, we can see the arrows, but we don't have anything to see yet. That's okay, because what we're going to do is start with the fundamental of what Game Object is. Everything in your game is a game object, okay? And what that means is that everything in your game can be turned on or off, and it has a transform. That is the very core of your game object. Transform means it has a position, XYZ, it has a rotation, XYZ, and it has a scale, XYZ. Now, if you'll notice, if we move this, it's doing exactly what you expect to do. It's changing the X position, and this is changing the Y position, and so on and so forth. Same thing for rotation. You're rotating the object. So let's get back to 0. Click in this little, let's go back to 0. That's important, by the way, I'll tell you in a second. So now that's cool. So now we know what the basis is. Game objects all have a transform, all have a on or off, and a name. So this is what every game object will have. But we can't see anything. In fact, if I don't have it selected, you can't even see the gizmo, right? It still looks like we have nothing. So let's put something in the scene that we can actually see when, you know, it's rotating or it's jumping up and down or whatever. So let's go ahead and delete our empty game object. Just click on it and hit delete. And now let's right click and let's go to 3D object and let's make a cube. Cool. Now we have something we can see. And if you click on your cube, you'll notice it too has an on or off, and it has a transform with a position, rotation, and scale. That's pretty cool, right? All right, we have an item that we can see. So let me, before I go through all the stuff that's over here, let's show you some of the tools in Unity. So with the cube selected, up here on the top left-hand corner, we have the move tool, which is what's by default selected. And if you select your item, you can move it around just as you expect. And again, anytime you need to reset, Control Z works to undo whatever you've just done, or you can click on the reset up here. That puts it back to 0. So you have the move tool, and then you have the rotate tool. So if you click on that, again, you have your option of moving stuff around as exactly as you would expect, rotate X, Y, Z, right? You'll notice in our game view, it's also rotating or being manipulated, however, right? So reset back to 0. And we also have our scale tool, which is just the size. And again, notice each one of these things has a X, a Y, and a Z, right? So if we expand that out, notice our Z is changing. If we expand this out, our Y is changing. And again, with these tools, if you select the middle, it's going to expand everything, right? So X, Y, and Z proportionally. Cool. All right, we are making some objects and we're moving stuff around. This is going quite well. Let's go ahead and reset it back to 0 and pause just for a minute. Anybody behind? Anybody have any questions? Nope. Nope. All right. Man, you guys are a smart group. I thought for sure we was going to have some questions. All right. Cool. We got an object. Now, most of you in here, I think, are engineers, so you kind of want to get to some coding and whatnot. We're going to get to that, I promise. Just need a few more things to set up with the engine here. So we have some tools. You have other tools up here. You guys can explore those later. Those 3 are the big ones. You can rotate, you can scale, and you can change position, right? Those are the big ones for setting stuff up. So we have our cube. Now, down here in our assets, we have our scenes folder. Let's go ahead and make us a new folder. So right click on assets, go to create and folder. Let's name our folder scripts. Cool, cool. So let's do another folder. So right click, create and folder. And let's name this one materials. We're going to get to what materials are in just a moment. Okay, cool. Now the other thing that I want to do just to make things a little more easy on the eyes is right now we have our camera set to what's called a skybox, which is where you can just see everything around. Think you know, a big circle around your scene. Just so that we can see stuff better, click on your main camera and change skybox to solid color. You'll notice that turns everything to some color. And you are welcome to set it to whatever color you want. I'm going to go with a very dull gray background, just so that we have good contrast. And that's the only reason I chose that color. Right, Jenny? Right. So, yeah, we got a nice contrast. We can see our block in our game view. Our camera's out here. That looks good. All right, so we have an object on our screen. It doesn't do anything, right? It doesn't jump, it doesn't move, it doesn't even have physics. But that's okay, we can change that. First, what I'd like to do is just show you, if you click on cube, to the right side, we have our inspector. Now, the inspector does, again, what you would expect, is it tells you what's on this object. So, step back. We have a game. A game works exactly the way that an application does, in that it consists of, when you start running that application, it starts a loop. And that loop is very simple. It says, am I still running? If that's true, then do everything that's inside that loop. Games are exactly the same way. When you click on play, it says, am I still running? Cool, do everything inside my game loop. So inside the game loop, what is happening for every object that you create is it's coming through and it says, is there anything in any of this that I need to execute in my game loop? And for every loop, or as it's called, a frame. You probably heard the frame rate. It extra everything in there, which is why if you have a million things going in your loop, your frame rate or FPS frames per second goes to crap, right? So that's why people are like, what, game's only 20 frames per second, or yeah, we're getting 60 frames per second. That goes back to how well you've made your game, because it's executing a bajillion things inside of it. So everything on here is what makes up this cube. You have a cube, a mesh renderer, a box collider, so on and so forth, but it is all composition. So everything is a base transform and then whatever it is made up of, okay? So you'll notice that it, by default, because this has a mesh on it, it has a material. This is the default material. And a material is what tells the camera what it looks like. So what color is it? What is the shader that's using? What is the reflection level? Things like that. So you can make your own materials. So let's go down here and double click on materials. And we're going to right click, create, and go to material. Okay, we're going to name this material cubes or cube, whatever you want. We're going to, and just so that we have something to distinguish it from something else, we're going to change the color to, I don't know, red, right? Maybe not that dark, but yes, red. Okay, and now anything that we put this material on is now going to have those properties. So if we click on cube and we drag this material over to this cube, boom, it's now red. And you'll notice the material that's on it is now cube with the standard shader. Cool. So that what that means is that no matter how many things have this shader on it, I mean this material on it, if you go and change that single material to say, I don't know, blue or whatever, you'll notice it changes on all of those. So that's handy because you guys are going to definitely be, making things various colors, right? All right, so materials. We've knocked out materials. That's good news. All right, so we've got material. Now we're going to work on.
I got left behind. How did you drag the material to associate it with the cube?
Okay, so there's actually two different ways you can do this. I clicked on cube so that I was inspecting it, and then I drug the material over to it. You can also drag a material up directly in the hierarchy and set it on there as well.
Where did you drop it on cube? Oh, you drop it.
Yeah, just you can either drop it over in the inspector or you can drop it directly onto the game object.
Oh, work to drop it on the game object. Thank you.
There you go. All right. Hey, who was that?
David.
All right, David. Cool. There we go. See, that's good. That's good. I like questions. I bet there were 3 other people that were trying to figure out that exact same thing, but we're too scared to ask. So good on you. Okay, so materials are cool. Now let's go down and let's start doing some script stuff. So we've got a box, but it's not really doing anything right now. So let's go down to scripts and let's right click. So yeah, select scripts so that we're in that folder and right click, create C# script. By default, this is going to name this new behavior script, but we're going to call this rotate. Okay. Now, we're going to have to semi-pause here. And the reason being is that Unity, for whatever reason, this version does not auto-associate C# scripts with whatever your editor is. So you guys bear with me. We're going to walk through this, and I fully expect some people to have issues. First question: is anybody in here not using VS Code for their editor?
I'm on a Mac with IntelliJ, but maybe I'm just.
You may be on your own.
Okay.
No,
don't worry about it.
We're gonna try. We're gonna try. It's just that if you're not using VS Code or Visual Studio or Writer, I don't know how well IntelliSense is going to work for you, but we'll try. Okay, we'll give it a shot.
Okay. Is there a place to copy and paste the code from?
No, it's okay. I mean, if whatever's associated with the CS file and the C# file, it'll open. It's just whether or not you'll have all the niceties that like the IntelliSense and whatever. So let's see what happens. Maybe it'll open up and be wonderful. Let's find out. But for those of you that are using Visual Studio Code, go ahead if you would and click, and this is going to take some doing on your part, and you'll see why in a minute. But click on Edit and Preferences. And in here, you're going to see, oh, make sure that you're on External Tools. Make sure that everything in here is selected. Everything all the way down here. And then what you're going to probably have to do is go find VS Code. So click on, I already have mine, but click on Browse. If you don't see Visual Studio Code in here, or Visual Studio, whatever you're, or Writer, or whatever you're trying to use, but click on Browse. And what you'll have to do is go find your VS Code. Now, David and Jenny were helping me out with this earlier, and by mine is I've installed it in a different place, but by default I think it's in your app data. So yeah, so you got to go like to your thing, and then you go to app data and something like that. It's like app data and then local, and then I think Visual Studio. Is David in here? Yeah. David, are you there?
I'm the David who's on the Mac.
Oh, yeah,
Is there
but
another David?
Yeah, there's another David.
I don't think so, though.
Oh, maybe he's just here in spirit. I see his name down there, but he logged in and split. But
Oh, no,
yeah.
I'm here. My bad.
Okay. Well, I was just thinking that if you wanted to tell the people the default location, that might help.
Oh, I didn't save mine in the default location either. I found it by right-clicking, going to properties, and copying the target.
Uh-huh. Oh, so you went down to your VS Code shortcut?
Yeah.
Oh, okay. Yeah, so if you guys want to do that, if you open the location to VS Code, it will up here. It'll give you the big long, or actually you can't see that on your screen, can you? It's like C:\users / whatever your name is / app data roaming Microsoft. Yeah, and you'll point it to your VS Code, right? Yeah. If anybody has any issues getting that to come up, let us know. It is kind of a pain, but once you have it set, what you'll see is something like this, where you have Visual Studio Code and it'll have like project path and so on and so forth in it. But you do need to point it to your code.exe so that you'll see some of the niceties. So does anybody have any questions about getting that or need some time to find that?
Vast, unrelated question.
Uh-huh.
For naming your scripts and your materials, is there a convention you use?
Not really. In general, your scripts will be what they're doing, right? As opposed to, like, you wouldn't want a full collection of it's composition over inheritance, right? So your game objects are made up of a bunch of different things that get executed, as opposed to one big class or something like that that's doing stuff. So that's why, like, so for instance, I did rotate. This script is literally going to rotate the game object and nothing else, right? So you want to keep it small and compact, but as far as materials, not really. I mean, this really is just, I'm putting this on cubes, but this could be very well like the color red, or pebbles, or really anything. So yeah, not a real convention. I will say you will almost always see projects set up just like this, where you have like a scenes folder, a scripts folder, a materials folder. You'll have like a prefabs folder, stuff like that. So it is pretty standard to see a resources folder. You'll see this set up. There's even in VS Code, there's some Unity extensions that automatically create a directory structure for you. But now, I mean, convention, same as normal. Try to be specific without being crazy, right? Good question, though. All right, guys, we're going to try opening this and see what you guys come up with. If anybody has any questions or needs us to pause, please, let's do that so that everybody's on the same page. So I have mine set to VS Code. Now, when I double click on this, whoops, there you go. It's going to bring up this. So you'll notice, by the way, I don't really expect anybody in here to be a C# coder. You should just, but it is under the assumption that most of you have some coding experience so that you can at least understand, you know, loops and stuff like that. The rest is kind of, it's not nearly as important. You won't even, especially in game dev, or at least in early stages, you won't get into anything super thick. You won't be doing a whole lot of .NET stuff, anything like that. So you really don't need to know C# so much as you just have to kind of understand programming flow. So this opened up the rotate script, which you'll notice I am including the game engine, but it does that by default because this extends from mono behavior. Now this is important because any script that you want to attach to a game object has to extend mono behavior. That's what allows the game loop to call on it. So it automatically put two methods in here. Just by default, it puts it in there, and they're not required, but it puts it in, the template puts it in there. The update method and the start method. So if you remember, and of course the name of the class is rotate. If you remember, I said games work just like apps. So they start their game loop and they go to each of the game objects and they say, okay, you have a mono behavior script. When the game starts, I'm going to run everything that's in the start method. And every loop that the game goes through, I'm going to run everything that's in the update method. So if you want your object to move to the right every time that the game loops, this is where you put it, in the update method. If you want it to execute one time whenever the game first starts, this is where the start is. Now there are other methods that are automatically included in mono behaviors, but you guys can learn about those, you know, later. It's not vital now. Okay, so we're going to make this rotate. Again, this is particular to whatever game object that we put it on, right? So it automatically has, but because we have extended mono behavior, it automatically has everything that that pertains to this game object in it. So let's say we want this game object to rotate. We're going to type game object, and then we're going to hit its transform, because remember, transform controls position, rotation, and scale. Okay, and then, now, this is why Unity is one of the best game engines, and I would even say the best game engines to get started in, because not only is the barrier entry low, but anything that you have, any question that you have, I almost guarantee you that someone else has had it. And so what we're going to do is go over here to the browser, and we're going to say, Unity, how do I rotate a game object? And ta-da, first thing that comes up, transform rotate. Not only does Unity's documentation have very good descriptions, very good documentation, they will tell you everything that the methods actually have, and they'll even give you you know, examples. So it's a really, you know, I'm telling you, just about any question that you come up with, type it in Google, and it's like Stack Overflow on steroids. It's got tons and tons. Everybody's already had the same problem you had. There you go. So now this looks complicated just because it's an example, but what we really need is just the method for rotate. So we're going to go back to our script. We know it's in the transform, and we're going to type row, and sure enough, there's our IntelliSense telling us rotate. And if we look, okay, rotate wants a vector 3, which a vector 3 just means 3 points, X, Y, Z, right? And so we're going to say, okay, vector 3 and up, so that it's on the Y. So we're going to have it spinning on the Y axis. So that means every frame, it's going to execute this code, right? So we're going to go back to our Unity thing here. And now if we click play right now, nothing's going to happen, right? Why? because we have not put that script on any game objects. So we're going to get out of play mode. By the way, just quick pro tip, because this will save you a lot of time. Anything that you do to this scene while you are in play mode gets undone when you get out of play mode. The reason I mention that is because I have full on spent an hour doing development in play mode and, and then lost everything because I was in play mode and I came out. So be mindful, just a pro tip there. So we're gonna make this thing rotate. So we click on our cube, and just like we did with the material, we're gonna drag our script over to it. And again, you can drag it up here to the game object if you want, but we're gonna do that. And now you'll notice our cube now has the rotate script on it. And so when we click on this, whoops, my zoom controls are getting in the way. When we click on this, ta-da, we have a rotating cube. Congratulations, everybody. You are professional game developers. Yay. All right, that's a pretty good step though. So just to take a beat, does everybody understand that this is running a giant game loop? It's going through all the objects in our scene. It's saying execute the update method on every single one of those for every frame. Everybody understand that? Any questions?
Yeah, I have a question.
Sure, shoot.
The rotate script didn't update inside Unity when I saved it out from my editor.
So you saved it and went back to Unity?
Yeah.
And then you clicked on this and it doesn't look like this over here?
Oh, it does actually. Oh, cool.
Yeah.
When I clicked play, it didn't actually rotate.
Okay. So just another tip. Remember I mentioned at the very beginning of the call that Unity was a beast? You'll notice that if you make updates in here and you save it, when you go back into the Unity engine, there's usually like a tiny stutter or a pause. And the reason why is because every time you make a change in one of the scripts, whenever you go back to the Unity engine, it recompiles everything. So there is yes, and obviously the bigger the project, the longer that might take, but it does just compile the changes. So it's not instant, but it's pretty fast. So yeah, that may have been what happened to you, is you may have just hit play before it actually finished its recompile.
Actually, I got a compile error.
Uh-oh. See?
CS1002.
That's okay. Here, do you want to look at this code so you can pair up? So make sure the object is a capital O.
Game object dot
transform
dot rotate vector 3 dot up.
And make sure you have
semicolon.
Yes.
Aha!
Oh, that gets you every time, won't it?
Thank you.
I got you, man. Trust me.
I've been coding in Groovy where the semicolons are optional.
There you go. Hey, let's just like Go. I love the way that Go does it. But anyway, okay. Nor here nor there. All right, cool. We got a rotating block now. Yes?
It's compiling. Woo!
Cool.
And rotating. Yay, thank you.
All right. So just so everybody knows, again, we're passing in a vector, and if you put the mouse over, you'll see that this is shorthand for writing 0, 1, 0, which mean it's moving 1 meter, 1 game meter on the y-axis. That's why it rotates the way that it does, and it's by 1. Now, if you were to say go in here and multiply this by 2, it's a float value, so 2f, now it's going to spin faster, twice as fast, in fact. And we'll just do that real quick since we're not in a hurry. How are we doing on time? 3:45. All right, we do all right. Again, notice my little little pause there, right? And then when we hit play, it's going to rotate faster. There we go, twice as fast. Cool. All right, so we have a rotating block. That's a good start. But we still don't have it doing, I mean, you know, in games you have physics and you have stuff that you want to do. You don't want stuff to just hang in midair, right? So I wouldn't say final, but the bigger one that I want to show you guys is that to have physics on a game object, you have to add what's called a rigid body. So if we go over here and we click, and rigid bodies are built in. In fact, I mean, it is at its very core, without all the tools and all the lovely stuff, at its core, game engines are physics engines, because nobody wants to compute physics for every frame, right? So that is what makes everything so much better. So we're going to click on Add Component, and we're going to type in rigid body. You'll notice it pops up as one of the things. And adding a rigid body, and again, just to take a step back, because I really want you guys to understand the fundamentals of what's going on here, is that this is one game object that is composed of multiple things, right? It's got the rotate script, the rigid body, and so on. So at every frame, every one of the game loops, it's going to go to each one of these things, and it's going to execute each one of these things on here. A lot of them are built in. You know, you'll add different shapes and so on and so forth, and colliders and so on and so forth. But it's important for you guys to understand that it is composition, right? So these game objects are composed of various scripts and so on and so forth. So, but we just added a rigid body. By default, it has a mass of 1. It is set to use gravity. The other stuff, don't really worry about. You'll whatever. So when we hit play, because we now have a rigid body and it is using gravity, what should happen is that this thing should just basically drop off the screen. So let's see what happens. Boop. Bye. Oh, and it rotates because we have the rotate script on it. So yes, our cube is now infinitely falling. By the way, notice, remember I said anything that you do in play, it resets it. Notice the cube jumped right back to our stop when we came out of play. So that, again, is important. So now we have physics. Cool. All right. Now, the last thing that I kind of want to show you guys, which is going to take a little bit longer to do, is just simply because this last thing kind of puts you at a place where, hey, if I wanted to make Super Mario, I'm on my road to doing this. And that is colliders. So we have game objects in the game, and in order for them to know when they've run into something else, what they have is a collider. And I will show you this collider. A collider, if you think, the easiest one to do is think sphere, right? So your collider says, I have a point in space with a certain diameter. And if anything comes within the radius of this space, another thing that has a collider on it, I now have a collision, and I want to, let the rest of the engine know I have a collision. And you can do whatever you want. Maybe you want an explosion to happen. Maybe you want it to bounce. Maybe whatever. But you have essentially fired off that event. I now have a collision. So you do that with, and this, by the way, your 3D objects automatically have it on here, is this box collider. And if I turn off the mesh renderer, you can actually see that in the scene view, the lineup for the collider. If you guys look at this, right? So this means if anything comes within the cube collider around it, then we have a collision, right? And you can see that by default it's the same size as your mesh, but you can actually change it. So if I want my collider to run into stuff that's that far out, I can do all of that. And I'll show you guys that in practice. So to demonstrate that, let's go ahead and make a couple other things. Let's right click on our cube and let's duplicate it. Now we have 2 cubes. You can't see because they're in the exact same spot. That's okay. And then let's go over to our transform for the first cube, and let's put that at x of -2. That's going to move that over there. And now let's click on the next cube and let's make its x a positive cube. That's going to space it out there, right? Cool. And by the way, because we duplicated that, it has everything that the first one has. So if I click play now, both of these cubes are going to start rotating and they're both going to drop. Perfect. All right. Now, just so that we have a contrast here, let's right click and let's create another 3D object, cube, and let's name that. Oh, just so you guys know, yes, you can name things other than cubes and spheres. You can name it whatever you want. Let's name that third cube ground. Cool. And let's lower that to like negative, what, 4, negative, maybe negative 3, doesn't have to be. It's just an example. And we're going to, oh, you know what? Let's pause just real quick. I just want to show you guys that in the scene view, this works kind of like a first-person shooter. So if you hold down the right mouse button in here, you can look around, and if you use your ASDW keys, you can actually, you know, go around. That way you can see stuff at different angles. You can see whatever. There's quite a few other shortcut keys. Like if you wanted to zoom in on this thing, you can double click on it and it'll zoom in. Your mouse button will scroll in and out. But just so you guys know, you can move, there's a reason that the scene view is what it is, not so that it just stares at one direction. You can actually completely look around your scene view. Sorry, I probably should have threw that at the beginning, but now you know. Okay, so we have our ground, and again, kind of pay attention to this in the game view, because this is what your players are going to see from the camera's perspective, which, by the way, cameras, you can totally throw scripts on and manipulate and change rotation and whatever you want, right? So it is just another game object like anything else with the composition of camera and audio listener on it. So be aware. All right, so our ground, let's make our ground, let's change the scale to like 20 on the X and 20 on the Z. That's going to give us a nice big flat platform that we can kind of see stuff on. And so that we have a different color for our ground other than just sheer white, because nobody likes that, let's right click on it and create another material, and let's name it ground or whatever you'd like. And let's make it, I mean, again, this is all up to you guys, whatever you want. I'm going to make mine sort of a, I don't know, grass color-ish thing. And then, of course, you want to put that material on the object. So when I do, it should turn green, right? Boom, nice. All right, we're making headway. So now we have a giant cube at the bottom, and we have 2 cubes at the top, which means when and each one of these all have a collider on them. So when we hit play, this should drop down. When it hits the ground, it will have a collision, and our cubes should continue to spin, but they'll stop at the ground instead of continuing to fall. Cool. All right, we are making some headway. Now, one more thing. Whoa, what's that? Oh yeah, see, we're making progress. I hear cheers from the crowd. It's exciting, right? I know. Look at April; she's super excited. Okay, cool. Okay, just to pause. Anybody having any issues? Any questions? 5, 4, 3, 2, 1. All right, cool. All right, we're going to do one other thing just to kind of show you guys how to use the rigid body and so on and so forth. And that kind of, again, at the end of this tutorial here, you guys can totally imagine we now have platforms and objects that we can move around and do things with. You could totally make your, you know, Super Mario Brothers clone or something along those lines, right? So just to show you guys a little bit more on the game loop, we're going to right click up here in the hierarchy again, and we're going to go to 3D object, and we're going to make a sphere. And again, get in the habit of resetting your transform anytime you create a new object, just because for whatever reason Unity always puts it in some random spot in world space. It's crazy, but anyway. All right, so we have now in the middle, if we reset that, we have a sphere, and it's between our 2 blocks. It does not have a rigid body. It does not have the rotate script on it, right? So when we click on play, the 2 boxes should drop and rotate, and the sphere should sit there in midair doing nothing. There we go. Cool. So, David, are you there? Jenny, are you there?
Yep.
Yes.
Jenny? All right, cool. Just in time. So, Jenny, if I throw a rigid body on the sphere and click play, what's going to happen?
It's going to fall like the cubes.
Right. And then when it hits the ground, is anything going to happen?
No, it's going to stay on
That's
the ground.
right. Man, you are nailing it. All right. Cool. So let's do something fun. Let's just so that it's not again pale or whatever. Let's create a new material, and let's call it sphere, whatever. Doesn't really matter. And we're going to just so you guys can see it happen. I'm going to go ahead and put, even though I haven't changed it at all, I'm going to put the sphere material on, and you'll notice that it doesn't look like it's done anything, which it hasn't, other than set itself on there. But now when I change the sphere to say like blue or something along those lines, now it changes as it go. And the reason that I mention that is because if you have 50 objects on the screen that are supposed to be blue, and then all of a sudden somebody says, oh, well, those are supposed to be red, you absolutely wouldn't want to go to each one of those things and change it to red, right? No. So this way, we can utilize it. All right, cool. So we have a blue sphere. Now let's go to our scripts folder. And oh, real quick, let's add a rigid body onto our sphere, just so that when we click play, now everything should drop and yeah, it's hit. Cool. Now let's go into our scripts folder and let's create a script. Again, create and C# script, and let's name this script bounce. Cool. Let's open that up. So double click or hit enter, whatever. And again, just so that you guys are familiar with the setup here, we have our class named bounce, and it extends mono behavior. So we have all the stuff from mono behavior. We have our start, we have our update. Let's go ahead and create a variable. This is important for exposing our stuff to the engine. So we're going to create a variable called, or well, not called, but a private variable, just so it's not exposed. And we're going to call that rigid, or of type rigid body, and we'll call that RB. Whoops. Sometimes IntelliSense doesn't help you. All right, cool. So now we have a variable in this class called RB, and it is of type rigid body. And we will do this so that we don't have to go look up the rigid body every time. And in the start, meaning it's only going to execute once, we're going to get reference to our rigid body. So we're going to say RB equals get component. Again, you'll notice IntelliSense is filling it out for me. And the type that we're going to get is rigid body. So what we're doing here is when the game starts, it's going to say, hey, does this game object have a type on it called rigid body? If it does, cool. I'm going to assign that to the RB variable. Great. Now we're going to do something with that. Every time that we have a collision, so there is a method called on collision enter. Get rid of this void, sorry. On collision enter. God, this is ugly. Sorry. There we go. On collision enter. And you can, and this, by the way, is something built into mono behavior, but as you can guess, this is going to fire anytime that this object runs into another object. So, like for instance, when the sphere runs into the ground, we want something to happen. So what we're going to have happen is we're going to call on our rigid body, so RB, and we're going to say, okay, now this again is working off a rigid body. What I want to do is I want to add force, and I want to send that up, vector 3 up, right? And now that would be adding a force of 1, which is not nearly enough. So what we're going to do is we're going to add a force of maybe 400 F. 400, that's a float. So we're multiplying the vector 3 up, which is 1, by 400. So that's going to add 400, the force of 400 up. and it's going to do that every time that it collides with another thing, which is going to be every time it hits the ground. So let's save that. Everybody with me? Anybody need this screen for another second or so? I can actually zoom in here a little bit too. Make this a little bigger for you guys. Yeah. Anybody? Everybody with us? Cool, cool, cool. All right, let's go back to Unity. And obviously it wouldn't do anything at all if we didn't have the script on our sphere. So let's drag the bounce script over to our sphere and let's hit play. And so what should happen, if we haven't botched this, is when this sphere drops down and it hits the ground, it's going to cause a collision, which is going to call this method on collision enter, and it's going to do whatever inside of it, which is going to, we're telling it to add force to our rigid body in the direction of up times 4,000 or 400. All right, so let's see what happens. Boing, boing, boing. Isn't that great? Man, you guys just made an awesome game. I'll pay you $5 for it. Right? Everybody made this game? David, Jenny, everybody?
Best game ever.
Ever.
Yep.
Cool. So just to recap, because that's kind of the point that I wanted to get you guys to, is to understand the way that game objects are made up. Meaning I could add 500, I could even, you won't be able to see it because it's a sphere, but I could totally throw rotate on the sphere and it would start rotating. You can change the scale, you can add force, you can do translate to move it around, so on and so forth. But the objective here today of today's talk isn't to get you to where you're making some new game. It's simply to get you guys comfortable enough with the engine so that now whenever David says, oh, you know what, Jenny, we should make a Hangman, or we should make a new VR game, or we should make WoW, you can at least say, okay, well, we know we got to create some characters, and we know we got to be able to push up and go this way and so on and so forth. And we know that the documentation for Unity is so awesome that anything that we run up on, we can totally type into Google or go into one of the chats or anything, and boom, we're ready to go. Yeah, I think that's pretty good. Again, moving around scene view, you can totally zoom in, you can move around, you can see our objects as everything's playing. When you take it out of play mode, you're back to square one. You can pause. You can, oh, you know what? I tell you what, let me show you guys just one other thing before we wrap it up. And we're at 4 o'clock, so it's about time. But so far, we have no real, outside of dropping scripts on our game objects, we don't have any interaction in here. So let's expose some variables to the Unity engine so that we can make adjustments. Let's go into our rotate script. Okay. In rotate, let's create a variable called a float variable called speed. And we'll just leave it, well, we can, it doesn't matter, you can set it to default or whatever, but yeah, let's set it to 1F and 1F, and by default it'll be at 1F, but we're going to rotate this not by a hard-coded 2F, but instead we're going to rotate it by speed. Now if I save this and I go back out into Unity, you're not going to see anything different because this isn't exposed to Unity. In order to expose it to Unity, you put this in a tag helper called serialized field. So I put that up there, I save it, I go back to Unity, and now when I click on the cube and I look at the rotate script, you'll notice I now have that control of that variable. By default, it's set to 1. But I can change that to, like, say, I don't know, whatever, 4. And now you'll notice I've changed this on this rotate script This rotate script is still 1. So this script, I mean this cube should rotate quite a bit faster than the other one. So let's give it a shot. Yep, see there? And in real time, as long as it's exposed to Unity, you can actually adjust this. So, and you know, that's quite a bit faster. If I went negative, it's going to rotate the other way. And this is how you can expose variables to Unity. It's serializing it so that the engine has, you know, access to it. So like you could do the same thing for the amount of force that we're making this ball bounce with, you know, things like that. So that is another kind of a big one. So, you know.
So is there a way you can manually change the speed for multiple objects?
You could. You could, but that's a little bit further away from this tutorial. I mean, it would just simply involve creating like a controller, and then that controller casts an event to you know, to everything else. But yeah, nothing complicated, but yeah, you can do it. You can totally do anything like that. I mean, if I made a, let's just say I created a parent. So notice all of these cubes are all of these game objects. Man, this Zoom control thing is killing me up here. Sorry guys, you can't see it, but every time I try to go play, the Zoom controls come back down. But so this is a hierarchy, right? Just kind of like a file system. If I go on here and I create an empty game object that has nothing and does nothing, I can go up and I can take my 2 cubes, I can move those into this game object, and then they are a child of this one. So let's just say, for instance, I started rotating this parent object. It's going to rotate both of those because the children are dependent on the parent game object. Be careful with this, because if they are rotating and this is rotating as well, you can get some very wonky side effects where stuff is trying to rotate out of its render ability and whatnot. But no, I mean, in games, you will see massively deep hierarchies of different things, even just UI stuff, right? So when you create a UI, like say a text field or something like that, that you'll notice that even that is inside of a canvas. So you might have like 15 panels under this canvas, and all of those are controlled underneath the same one. So yeah, just think same thing you would in like web dev, right? Like you might create a controller, and that controller would send out an event to all of the ones that are pertaining to it, and you know, kind of go from there. That just about wraps it up. The only other thing that I kind of want to show you guys is just for you to have reference to another, let me back this up, to have reference to another game object. It does have the ability to drag and drop game objects. So let's say, for instance, we have, I don't know, say our cube script, our rotate script. If we go up and we did something like this, serialized field, and we did, this is a game object called Go. IntelliSense strikes again. There we go. Called Go, and then we go save that and go back out, and then we look at our rotate script. You'll notice there's another open, I mean, it has nothing in it, right? But if I take this game object, or say the sphere, and I drag that into this, now anything that the Go variable in the rotate script now references that sphere. So let's see, what can we make it do? On start, we want to go dot get component, and we'll hit the rigid body just to make it do something, I don't know, crazy. And then we'll add force, vector 3 up times 1,000. So because this game object will now, because we did drag sphere over to it, we'll be able to hit the rigid body that's on that game object, and we'll be able to add force to it. So, and because this is in the start method, what should happen is at the very start of this game, it should launch that that sphere up in the air. I don't know, quite a ways. Yeah, so send it way up off the screen, and yeah, and there it comes, right? And now it's bouncing. But yeah, but notice that that was actually from the cube because it has reference to the sphere. So also important, I mean, you think if you're, I don't know, shooting fireballs at something, right? Maybe you want to create a game object that represents the fireball, and then you could just simply continue to create those game objects over and over and over, and so on and so forth. But again, we're kind of getting off into left field because I really don't want to teach you guys to make games or a game here. The main objective of today's talk is just to get you guys somewhat familiar with this engine, so that when we start doing like the game jam, we start splitting groups up and whatever, you won't be able to go into the game and say, hey, here we go, we're just going to make this. But what you will be able to do is get with your group and everybody open up Unity and at least know where everything is, so that everybody can kind of expand from there. Hopefully that makes some sense. By the way, just real quick, notice I got a quick error down here. Is because this cube doesn't have reference to the sphere, and this one does. So when it tried to call go dot whatever, this sphere did not have reference to it, and it threw that error right there. So yeah, use your console, it's handy. Cool. So any questions? Anybody not feel like if we hung up this this conference call or this Zoom meeting, whatever, right now, that you guys couldn't recreate this from scratch? Is there anybody that does not feel comfortable with that?
This is awesome. Thank you.
Yeah, cool, man. I'm glad you're enthusiastic about it. Just to let you guys know, and Johan can get in on this too, but the hope for our game jam is going to be, I don't know, several weeks, maybe even a month, and the end product that we're kind of shooting for, because this group is 99.9% engineers. We don't have artists, we don't have anything like that. But fortunately, the other cool thing about Unity is that it has an asset store with, and you can get to the asset store by going to Window and Asset Store. It has an asset store that is massive, and it not only is it massive, but it has just, I mean, so many. If you go to the pricing thing and you drop this down to zero, like what can I get that costs nothing? It has 6,407, 47 result. You don't need artists to get something right. Like, so you guys see that I have these primitives bouncing around and whatever. If you dropped a player character, like some art asset on there, it's still going to do the same thing. Mechanics is still going to be the same. It's just going to be pretty, right? So, the asset store, you absolutely get in your teams, and you should absolutely be able to, if you don't have any artists in that team, that's okay. Grab you some free assets off the asset store, and boom, you're ready to go. Now, again, it takes years and years to become a insanely high depth game dev, because there's so many tools and so many disciplines that you can go into. But hopefully, but to get started, it's super easy. So yeah, and we have several people here. We have a few game devs. John O'Connor, which I don't think he's in here. He's a brilliant guy and super helpful. You can always ping him. Spencer does a pretty good job. We've got a few other game devs. I do stuff, totally happy to help with even the most base questions. So you guys get going, and you get an idea, you want to start playing around or whatever. If you have any questions, I mean, Jenny and David and everybody.
I have a question.
Shoot.
Is it possible to store, I know we have cloud and everything, but is it possible to store these Unity codes or programs onto an external device, like a passport or something?
You could, but I would highly recommend that instead you just start a repo and put it on GitHub, because then you have it everywhere and forever.
Okay.
Yeah. Highly
Gotcha.
recommend it. Yeah, I mean, even this thing, I initially opened it up and had it go into the IESD thing, but it's pretty basic, so it doesn't really need to be out there. But yeah, any project that you start first, literally, before I even like open the Unity thing and start a project, the first thing I do is create a repo so that your stuff is forever saved. It kind of is a separate talk, but do understand that game dev has binaries and thus assets. So that means if you're doing GitHub or something, you can't diff a binary. So if you save a scene or something along those lines, you can't just say, well, the difference between this one and this one is this, right? So be aware that it does compile to binaries, but like all of the scripts that I've done today, all of that kind of stuff, all of that is totally yeah, but you can push it all. So yeah, definitely recommend that day one. But again, that's another talk.
Okay.
But yeah, cool. Any other
So
questions?
Vast, if I
Yeah.
wanted to do a two-dimensional game, like a side scroller, would I take the same approach but instead use a two-dimensional object?
I'm glad you asked that. I wasn't going to cover that in this, but I'm going to tell you guys a really cool secret. There are differences between 2D and 3D games, but as far as making things, it is literally this simple. You go to your camera, and instead of this being perspective, you change this to orthographic. Boom. Everything you do is 2D. Notice if I move this cube around, I no longer have to be concerned about the forward and backwards, right? Because it's 2D, right? So it's just expanding or whatever. It's not, you don't have a 3D element, so left and right. But notice this is all 2D. And now I will say there are slight differences. Like generally, if we make a 2D game, we make that in 3D, but you have like sprites and stuff. So if you notice, when I went to put in the rigid body, there's a rigid body 2D, right? And same thing for colliders. If you go and you type collider, there's a box collider 2D, capsule collider 2D, and so on. And if you think about that from a programming standpoint, the calculations that have to happen for it to check if there's a collision from X, Y, and Z is considerably higher than just X and Y, right? So those are the difference. But as far as making the game, everything is the exact same. I mean, you deal with different assets and stuff like that. But yeah, it's really, it is as simple as, where is the camera facing? Does it see everything, or does it just see the orthographic view? So yeah, it's easy. If you notice, when I created the new one, there was actually a template for 2D, but the only thing that does is load a couple different modules for 2D. It is actually very similar. In fact, I was telling Jenny, who was talking about a VR game. Believe it or not, VR and even AR is not a whole lot more complex than any of this. Now, there's a design perspective that you go into, but people think VR is like, I don't know, a different universe. And really, it is. It's just about how you approach the design of it and how you interact with it. But yeah, I'm telling you guys, people think that this is like so far away from what they can do, but it really isn't. It is. And Unity makes it really nice for that. Cool. Anything else? Anybody have any comments, questions, concerns?
I'll make a general comment. For a couple of years ago, I worked with a social casino company.
Mm-hmm.
I was sitting between the Unity programmers, back-end programmers, the artists, the customer service, the game designers, and I was doing what's called live ops, where they could change in-game parameters from my UI.
Nice.
Like correct the number of chips that a player has when they found a bug in our system, and all of a sudden they have 1 billion chips.
Right. Right. You gotta be careful with that. Yeah, that's cool.
So it's very. I fired up Unity once. I didn't get anywhere. So this is really cool. I appreciate it.
Well, you've been very active here. I hope you, I definitely hope you participate in the game jam. There's the cool thing about the hackathons and the game jams that we do here is that there's no pressure, right? Like, it's not like you're winning a car at the end of it, right? Like, we're all just sort of like learning together. So yeah, it'll be fun.
Yeah, my wife's been in the special effects and animation industry for 30 years.
Really?
She doesn't program the animation or do the art. She's in pipeline. She
Oh,
writes a Python script to help them move their assets around and get them through the render farm.
yeah. Well, that's a testament. I was talking when we first started is like this, the game industry is no longer like, five nerds sitting in a basement somewhere. It is it is expanded so far that it includes just literally everything that you can possibly do. And, there's a place for everybody in it.
Well, her company is paying for her to learn Unreal. So it's interesting. I'll learn Unity. She can learn Unreal.
No, that's cool.
We can have a little friendly competition.
And you guys can go back and forth because
the reason they want to learn Unreal is to do real-time special effects, so that as they're having the actors move around, they see the special effects at the same time.
Oh, that's dope.
So that they can actually put them in. They like have monitors and background scenes. They can do all this stuff in real time. It's called pre-visualization. Even beforehand, the concept people can sit with the Unreal person and actually change what the special effects will be in concept in advance of making their movie. Awesome. So that the special effects and the live action mesh a lot better. And Mandalorian is doing a lot of this. There's a company called Third Floor that uses this and has been for like 10 years.
So that they're having her learn Unreal. Are they having her do Blueprint stuff, or is she actually doing C++?
Good question. We'll find out.
Well, I was telling Catherine, she likes Unreal as well, and the cool thing about Unreal is because the way they have their visual scripting is being able to drop down and do C++ at the meta level is nice and all, but just from a designer's perspective, you can totally build like an entire game without touching code at all. So I imagine they might be pushing her in that direction, but that's totally dope.
Well, this is so she can support the other people who are doing that and help fix bugs on the fly and to make sure that they don't push out a version that's not tested.
That's cool. Yeah, that's cool.
It's nice to hear about what your wife is doing, because that's one of my big interests is Unity and Unreal Engine in respect to the entertainment industry. So like it's just huge in the entertainment industry. They did a concert with I forgot his name, but like all the special effects to the concert were done on Unreal Engine. And it was amazing because the concert was inside a dome, and on the inside of the dome, the audience could look up and see crazy images floating above them and things dancing over them. It was so cool. And then like with Unity, they did a movie called The Heretic.
Yes, it's awesome. If you guys haven't seen the video, you should go look it up. It's awesome.
Yeah, if you ever get a chance, I went to the USC Unity Day. They did that on the campus of USC, and they put The Heretic up in the auditorium with the movie screen. It was I don't even know how to explain it. It's like you totally get sucked into the movie because it's on the big screen and it's like your total focus. It's in 3D and it's got all these awesome effects. I really want to do this. I really want to move in that direction if I do Unity and Unreal.
Sounds awesome. Yeah,
Catherine, if you don't mind my asking, what do you do now?
Nada.
Okay, when we get to go out again, what would you like to be doing?
I would like to be learning how to use both the engines. Actually, I have to start with learning my Visual Studio and my Visual Studio Code because it's just so much to learn. It's so much to learn.
Cool. Do you already program?
I've learned, I've had courses in Java, Python, C++, and a lot of the stuff is outdated. That was, now that I think about it, it was almost 20 years ago.
The concepts haven't changed.
I hope not.
You're good. But if you're looking for an entry-level position when people can go back to the offices, you might look up a place called The Mill. They have an entry-level position from which people learn the company by meeting a lot of people. And those people move up to other positions, including the person who was the entire head of the whole office.
That is an excellent resource. You should totally post that on the Slack channel and the resource thing. That I think people would be quite interested in that.
Yeah, it's
Yeah.
a really stupid entry level, but Fran got one of her relatives to jump into it. And then he, within 6 months, he was into the kind of position he wanted.
That's awesome.
Are there any entry level, sorry,
no,
are
go
there
ahead.
any entry levels that are remote?
I don't think it has the same advantage of meeting all the people like that. That particular entry level is called runner, and you basically do what everybody wants. It's a London-based company, and part of the duties is making tea for the clients when they come in. And they teach you how to make British tea.
Nice.
Ooh, I could do
As
that.
such, you're running around the entire company meeting everybody. It's awesome.
Okay, cool. I've done run over my time, so what we'll do is just wrap it up. Let everybody know that the game jam thing. You want to throw out some more information out there. But again, any questions anybody has going forward from here, please hit us up on Slack. Throw it in code, anything you need, and we'll kind of take it from there. Thanks everybody for hanging out. Dawn, you have anything?
I have a question, Best.
Yeah, shoot.
So you said the competition had no new cars as a prize, but I had a rumor yesterday that one of our members, Miss Robin, has a new car. So
Oh,
Congratulations, Robin.
she already won. Congratulations, Robin.
congrats, Robin.
Thanks. That's funny. But yeah, let's reiterate, there is no car that we're giving away. So I don't want anyone
Nobody
winning
sue
and
him.
saying,
Bast
I
is
had a
over there
car.
sweating.
Yeah. Yeah, so thank you everyone for joining. This recording should be available by the end of the day or early tomorrow on our YouTube. I'll post a link as well. And as Vas mentioned, there is a competition coming. We're moving away from Hack Day. I'll post some of the reasons when we do release all the information. The operations team is working hard on making that happen, coming up with the rules and everything and all the structure. As soon as we have everything solidified, we'll post it out. But the main idea is that we want to make sure that everyone that joins has something substantial that they can show future clients or employers or whatnot. For Hack Day, you only have 4 hours of build time. You really don't have enough time to build anything that's presentable, right? So with this new approach, we hope that you have enough time to build something somewhat polished. And with there will be a requirement where you have to create some sort of presentation for it that's at least a minute. So a minute is not too much to ask. But again, all details will be posted at a later date. So again, thank you everyone for coming. And I believe that we're good with this meeting. Thank you.
All right.
Bye, everybody.
Thank you.
Bye.
Bye.
Bye.